Hey everybody, by the end of this video you should be able to classify matter in two different ways. You should be able to use the particulate theory of matter to classify something as a solid, liquid, or gas. And you should also be able to classify things as being a mixture or a substance. And again, that will also use a little bit of the particulate theory of matter. But first things first here, let's spend a little bit of time talking about using the particulate theory of matter in order to define the types of matter. There are solids, liquids, and gases. Okay, solids, the molecules are very close together. Liquids, they're a little further apart. And gases, they're very far apart. This is fundamental to us understanding how matter behaves. This is one of the things that is really exciting for me as a chemist, is to understand how solids are actually solids and why liquids are liquids and gases are gases. So let's take each one of these a little more specifically and look at them. So a solid, what we have are intermolecular forces keeping the particles together. Now, before we move along much further, let me take a minute and I'll show you what a solid looks like using the particulate theory. Okay, so you see these yellow balls down here. Okay, so I am going to use these as kind of a model of a solid. Okay, now these yellow balls are very, very close together. That's the way a solid is. Okay, now what is holding those yellow particles together? Well, there happens to be an intermolecular force, a force between these particles that is preventing something from going and pulling it out. Now, something else is occurring is realize that because of the force that are holding all of these molecules together, this particle can't move very much at all. Okay, now the one to really look at to understand why they can't move is this one in the middle. Not only is this one in the middle being attracted to by this, and this one, but also because it's surrounded by those, there's just not a lot of space for me to get in there and try to move around. Okay, so as I move it around, notice it just can't move. Okay, so it's not only because the forces are strong holding those together, but because there's not a lot of space in there that a solid is a solid. So that's one of the reasons why I appreciate what a solid is. Now, because of this, because they don't move very much, okay, the solids have definite shape. That shape is set. It's always going to be whatever the shape is. And the volume, the amount of space it takes up, is always going to be set as well. So you're not going to have random sizes and shapes. So that's the way solids work. So the forces between the particles are strong. Okay, these molecules don't have much motion. They're not allowed to move, not only because they're being held by forces, but also because there's just not a lot of space to move, and that gives rise to the definite shape and definite volume. So now we'll continue to look at liquids, and again I will bring in a representation of a liquid here in the bottom. So you'll notice that the particles in a liquid are separated. Okay, one of the things that happens is the forces that exist between them are still there, but they can be overcome easily. Okay, so this means that this molecule here that's in the middle, yes, is feeling an attractive force or an intermolecular force between the molecules, the particles that surround it, but it's able to move a little more freely without having to worry about some of the other particles around here. This guy is able to move around and come in and, you know, go up and down, and you know, you can worry about three-dimensional space. And this one, same thing, move around. And so there's a lot more motion for these particles because there are intermolecular forces, and they're weaker, or they're able to be overcome more easily. And so because of this, the amount of space that a liquid takes up is definite, but its shape is going to change depending on the container that it's in. So if I have a container that's a different shape, these molecules are free to move around to take the shape of whatever that container is. Okay? And so that's where we get the particulate definition of what a liquid is. So we really like that. Now for gases, and let me pop up a picture of gases for you. We have to realize that intermolecular forces, the things that are making these yellow particles attract each other, don't exist. It's not that they, in a technical sense, it's not that they don't exist. It's just that we just assume that they don't exist. They're very, very, very small, or they're very, very easily overcome. So this yellow particle can move independently of any of the other particles that are floating around in a gas. And so that means that the gas particles have the greatest range of motion. They can move independently, and they can do all sorts of crazy things. Okay, so because they move independently, and because we don't consider the forces between the particles a factor of any way, shape, or form, we say that they have an indefinite shape and an indefinite volume. Okay, so that's lots of neat stuff going on with the gases. Now that we know about this, tell me why. What state of matter is water in? Okay, you can pause the video, take a minute, figure out why, figure out what state, and then tell me why. Okay, so water. This is an interesting and kind of tricky question. Water is interesting in the fact that it's one of the only compounds that's found in nature in all three of its states. It's found in nature as water vapor, it's found in nature as a liquid, and it's found in nature as a solid. And so if you told me that it was a liquid, that's fine. But the more important thing is, why do you think that? Okay, well, you think that because it doesn't have a definite shape. Maybe you think that for a variety of reasons. But when you explain what state of matter something is in, I will expect that you should be able to tell me why. Okay? So instead of doing another 8 minutes on a second topic, I'm going to split this video in two. So feel free to move to the second video in this series about substances and mixtures. Thanks.